So here we are again on part 3, negative sequence made easier. And in this one, we're going to go over how to calculate negative sequence and zero sequence, just a little bit of sequence calculations to prepare us for the future. And so we did all positive sequences on the last one. Here they are. On this one, we're going to start, we've already done positive sequence, so we're going to start on negative sequence now. And what we're going to do is we're going to calculate what the negative sequence component is for these phasors, which are 100% positive sequence. So we expect it to be 0, and then we'll do the same thing again on phasors that should be 100% negative sequence. So we should expect the answer to be 100%. And then we'll do it again on phasors that are 100% zero sequence. And then we'll do that all over again for all of the zero sequence components a little bit. So let's do I2 equals 1/3. And this should cancel out anyways because this is expected to be 0 for the final result. But 5 amps at an angle of 0 degrees plus alpha squared. And I'm going to write alpha equals 1 at an angle of 120, and alpha squared equals 1 at an angle of 240. Okay, so we've gone over that in the last video. You can look back if you need to on how or why, but that's what those equal. So we'll go ahead and that's our phase shift compensation. So alpha squared is 1 at an angle of 240 degrees times our IB, which is 5 amps at an angle of negative 120, plus alpha, which is 1 at an angle of 120, times IC, which is 5 amps at an angle of 120. You combine all of your like terms and put it together, and you get your I2 is equal to 1/3 times 5 amps at an angle of 0 degrees, plus, well, this right here is going to be 5 amps at an angle of positive 120. Remember, add the angles, multiply the magnitudes. And then this last one right here is going to be 5 amps at an angle of 240. And if you look at this, you have 5 amps in this direction. And then the next one is 5 amps in this direction. And the next one is this 5 amps in that direction. And if you were to add these phasors directly, and a cool trick that you can do, and I'll just kind of do it over here. Just imagine that you have it like this, and like this, right, on the right-hand side. If I were to take this red phasor and just move it, transpose it right over here. And so the start is no longer on the origin, but I moved it over here. It's still the exact same thing. And then the blue one, let me change my color to blue. And I move blue down here. So its starting position is right here. You can see that you get back to the 0. So that's what it means by adding them instead of multiplying them. Okay. So hopefully that's a little clearer. So our resulting answer is going to be I2 equals 1/3 times 0 amps at an angle of 0, which is just equal to 0 amps. Okay. So we expected that. This is a 100% positive sequence system, and we're doing the negative sequence calculation. So we expected it to be 0. This one, though, should be 100% negative sequence because this is our phasors are swapped. We have this rotating in the reverse. This is C phase, A phase, and B phase, and they're rotating in this direction. So this one is reversed. And so on this one, it's going to be I2 equals 1/3 times 5 amps at an angle of 0 degrees plus 5 amps at an angle of 120 times alpha squared, which is 1 at an angle of 240, plus 5 amps at an angle of negative 120 times alpha, which is 1 at an angle of 120. And then you're going to close that. And so we have I2 equals, let's combine like terms. And what do we have? We have 5 amps at an angle of 120. Excuse me, that's at an angle of 0 degrees plus, well, this is 5 amps, multiply the magnitudes, add the angles. 120 plus 240 is 360. Well, that just gets you all the way back to the origin, which is 0. So this is 5 amps at an angle of 0 degrees plus, and the same thing happened here. It's just 120 minus 120, which is 0. So 5 amps at an angle of 0 degrees. You can see that this is just 5 amps at 0, 5 amps at 0, 5. It's 3 of these. So you can cancel out the third and just say this I2 equals 5 amps at an angle of 0 degrees because there's 3 of them. And lo and behold, that equals the same thing as A phase, which ideally indicates that you have 100% negative sequence. The last one for negative sequence is right here in these values. And so we expect these to be, this is a 100% zero sequence system. So I2 equals 1/3, and we expect the third to not matter, but IA is 5 amps at an angle of 0 degrees plus 5 amps at an angle of 0 degrees with an angle compensation of alpha squared, which is 1 at an angle of 240 plus 5 amps at an angle of 0 degrees with an angle compensation of alpha 1 at an angle of 120 degrees. Close all that out. I2 equals 1/3 5 amps at an angle of 0 degrees plus, and this is 5 amps at an angle of 0 and 240, which is 240 degrees, plus 5 amps right here, multiplied by the magnitude here, but also you're going to take the angles and add them, angle of 120 degrees. And this, if you look at this, this is 5 amps at 0, 5 amps at 240, and 5 amps at 120. Again, these will all cancel out, and you'll just be left with I2 equals 0 amps at an angle of 0 degrees. That's because this is a 100% negative sequence phasor system, okay? And you're trying to calculate the negative sequence. So that's both of those done. The next one we're going to do is zero sequence given positive sequence vectors or phasors. So this is A phase, B phase, C phase. And so I0 is actually easier. There is no alpha in this at all. You can see that it's completely gone on all three. You just add the phasors. So it's 1/3 times 5 amps at an angle of 0 degrees plus 5 amps at an angle of negative 120 degrees plus 5 amps at an angle of 120. And if you think about it, all we're going to do is just take this, move it over here, take this one, move it over here, and you can see that these all cancel out. So this is 0 amps at an angle of 0 degrees. You could, like I said, convert these directly to x, comma, y values, and then add up all of your x's and all of your y's, and then you'll have a total of xt and a total of yt, and then convert that back to a not r comma r at an angle of theta, right? You could do all the conversions back and forth, but I can just look at this and tell you I'm trying to shorthand this. The third no longer matters because you have 0, so your zero sequence on this system is 0 amps at 0 degrees. This is a negative sequence phasor system, right? And we're trying to calculate what the zero sequence is. So this is I0 equals 5. Oh, don't forget the third. 1/3 times 5 amps at an angle of 0 degrees plus 5 amps at an angle of 120 plus 5 amps at an angle of 240. That's what this is. Negative 120 is 240. Same difference, just looking at it from this direction or looking at it from that direction. I0 equals 1/3. And this is all, again, just going to cancel out. You're just going to do a vector sum. So it's going to end up being 0 amps at an angle of 0 degrees. And the third no longer matters because it's 0 times anything is 0. And the final answer is 0 amps at an angle of 0 degrees. The last one right here is what is the negative sequence here? And this is when the third matters. What is the zero sequence here? This is when the 1/3 matters because we expect there to be an appreciable amount. By the way, this 1/3 is the only difference between zero sequence and residual, okay? A residual is not this. You just get rid of this. And then this is no longer IO, it's just residual current. Okay? That's the difference here. So don't get those two mixed up. I0 equals 1/3, and this third is really going to matter here. And it's going to be 5 amps at an angle of 0 plus 5 amps at an angle of 0 plus 5 amps at an angle of 0. Ooh, if I could write. And if you look at that, that really just means it's 5 amps, 5 amps, 5 amps, which is a total of 15 amps, right? You can just stack them up. So it's IO equals 1/3 times 15 amps at an angle of 0 degrees. And 1/3 of 15 is equal to 5 amps at an angle of 0 degrees. And that's our final IO. Okay, so that's how you do this on all three of them. I didn't want to do a complex angle calculation. There are plenty of online tools and webinars and sources that you could use to learn how to do that. I just want to show you how to apply this to positive, negative, and zero sequence systems. So in the next one, we'll start going over the relays and some other stuff.